Hello friends, welcome to this second video on power spectral density. In the first video, we saw about the definition of power spectral density and the properties of power spectral density, as well as definition of cross power spectral density and its properties. This video will introduce you to few problems and a few hints which we need to keep in mind when we solve problems in power spectral density in general. We'll move on. Hint number 1. We need to keep in mind that when the input function is going to be exponential in nature, that is, we have been asked to find whether an rxx of tau or if it is going to be an sxx of omega, whatever be it, if the input function has been in terms of exponential, then what do we do is inside the Fourier there is also an exponential e power minus I omega tau. So if this input function is exponential, we keep this Fourier part also to be as an exponential itself. But if the input function is going to be algebraic in nature, that is, it is going to be in terms of omega or it is going to be in terms of tau and so on, then what do we do to this e power I minus I omega tau is we split and write it as cos omega tau minus I sin omega tau. So this will be the first hint we will keep in mind. If input is exponential, keep the Fourier as exponential. If the input is algebraic, we will have to split the exponential as cos and sin. The second hint is that whenever we have the modulus of a function as input, then we need to keep in mind this modulus is going to be a property like it behaves in two different ways in the entire range from minus infinity to infinity. From 0 to minus infinity, the modulus takes a negative value, and from 0 to infinity it takes an positive value. So whenever we come across a modulus function, then the integral from minus infinity to infinity has to be split into two functions like minus infinity to 0 and 0 to infinity. You cannot integrate them keeping it as one single function because this modulus behaves differently in two different zones. So in your minus infinity to 0, what is happening over here, this modulus will take a negative value, and in the interval from 0 to infinity, this modulus will take a positive value. This is going to be your second hint. The third hint is that if my integral has limit to be equal to minus infinity over here in the numerator or in the denominator, wherever be it, then keep the exponential as positive in nature. When you are pulling out term, you will have to keep this as positive, because when you apply the variable as the limit, when this limit is going to be applied for the variable, what will happen, you will have this to be applied as e power minus infinity, and we know that in which case the function can be moving towards 0. But if you keep it to be equal to negative, what will happen, e power minus of minus infinity will become plus infinity, and this will move towards an infinite value. So you will have to keep in mind, if the limit contains minus infinity, keep e as positive, and the other way around, if you have infinity as the limit, you will have to keep your exponential as negative. So if it is going to be negative in value, so e power negative I keep, then when I apply the limit to the variable, what will happen, this variable will take the value as infinity, and you will have this as e power minus infinity, and the value becomes 0. The fourth property or the fourth hint is that normally our signals are in terms of trigonometric function. So whenever final answers are in terms of exponential, we try to convert it into trigonometric equivalent forms, and the frequently used conversion will be, you can replace cos theta as e power I theta plus e power minus I theta divided by 2, and sin theta as e power I theta minus e power minus I theta divided by 2i. This is because you know that e power I theta can be written as cos theta plus I sin theta. And what is e power minus I theta? This is going to be cos theta minus I sin theta. So when you want cos, you will have to remove this sin. So how can you remove? You add them up. When you add them up, you have 2 cos. So it is cos theta, 2 times of cos theta will now be equal to e power I theta plus e power minus I theta. If you want cos theta alone, cross multiply this 2 to the opposite side. In a similar way, when I want sin theta, what will I do? I'll have to subtract this equation equation. When I subtract, what will happen? Cos will cancel off and you will have 2i times of sin theta, and since you want sin theta alone, what has to be divided by? It has to be divided by 2i. So the conversion for the replacement for cos theta will be e power I theta plus e power minus I theta divided by 2, and the conversion for sin theta will be e power I theta minus e power minus I theta divided by 2i. So we will keep these 4 hints in mind whenever we do problems in power spectral density. These things can make our task a little easy. So we will move on to see how this works with problems. The first problem is that the power spectral density of a random process x of t has been given as sxx of omega is pi for mod omega less than 1 and 0 elsewhere. What we have been asked? We have been asked to find the autocorrelation function. Given power spectral density, we want the autocorrelation function Rxx of tau. Rxx of tau is nothing but the Fourier inverse of your power spectral density. And how to define the inverse formula? Inverse means always there has to be the constant part 1 by 2 pi. Take your input. If it is negative here, you need to remember this is positive exponential. So e power I omega tau d tau. Okay, now what happens over here for my limit? Mod omega less than 1. So if I expand the modulus, it means that minus 1 less than omega less than 1. So this is how I can rewrite this interval as. So keep in mind, modulus will be spreading across from negative value to positive value. So keeping these things in mind, we will move on to solve the problem. So what will happen? The problem now becomes equal to 1 divided by 2 pi integral from the limit now is sxx of omega is my input. The input function is going to be equal to pi. So let me give the input function as pi. This input function is going to be pi, which is going to be a constant. So only if you have your input as exponential, you will have to keep this as exponential. Okay, so in which case what will happen? This constant is not going to affect you this exponential in any way. So we keep it as e power I omega tau, and this to be equal to d omega. And where does this pi vary? It varies between minus 1 to 1. This pi being a mere constant can be taken outside, and if this pi is taken outside, this can be cancelled off over here. So I have integral from minus 1 to 1 e power I omega tau and d omega. Now this is going to be our integration with respect to the value with respect to omega. Omega is going to be my variable, in which case omega is my variable, I and tau will become my constants. This is going to be my constant, this is going to be my variable. You will have to be very careful because you need to divide it, because we know that e power a theta d theta on integration gives you e power a theta divided by a. You will have to divide it by the constant. So which is the constant over here? With respect to omega, I is the constant, tau is the constant. So what will happen? So we have this to be 1 by 2 e power I omega tau divided by I tau. So this will be the constant by which I will have to divide by, and the limit varies between minus 1 to plus 1. Now which takes the values from minus 1 to plus 1? Omega is my variable. Omega takes the values between minus 1 and plus 1. So this gives me 1 divided by 2I tau. Let me apply the upper limit for my omega, e to the power of I. Omega takes 1, so this becomes I tau. Upper limit minus lower limit. What happens to my lower limit? Omega takes the value minus 1, I minus tau. So this becomes my lower limit. So you can stop over here, but we have already seen in our hint that it is best to express them in terms of trigonometric function. So what will be the trigonometric equivalent for it? You know that e power I theta minus e power minus I theta divided by 2i is nothing but your sin theta. What is in place of theta? You have it as tau. Now what is going to be this 2i? If I take it inside, I will be left out with an extra 1 by tau outside. So the final answer, which is the power spectral autocorrelation function, which is required for the given power spectral density, is going to be 1 by tau sine tau. We will move on to apply one more problem over here. Problem number 2 states that the power spectral density function of a zero mean WSS process x of t is given by Sxx of omega is 1 for mod omega less than omega naught and 0 elsewhere. We will have to find the autocorrelation function r of tau. Again, given power spectral density, we are going to find autocorrelation function. How are they related? Autocorrelation is nothing but the inverse Fourier of your power spectral density. So we recollect the formula. Rxx of tau is going to be your F inverse of your value Sxx of omega. If it is going to be inverse, you will have to keep in mind that the exponential will be positive, and so the second quantity to remember is that you will have to have an 1 by 2 pi outside, and integration is with respect to omega, so you will have to have d omega over here. So in keeping these 3 points in mind, we will have to now go for the limit. What is going to be the limit? Mod omega is less than omega naught. So if I am going to expand this modulus can vary between a negative and positive. So minus omega naught less than omega naught. This is going to be my limit of the variable omega, which I will have to integrate it for. So it becomes 1 divided by 2 pi. Where is my limit? It is not from minus infinity to infinity. It becomes 0 elsewhere, but valid only between minus omega naught to omega naught. What is the input function Sxx of omega? You take it from over here. The input function is going to be equal to 1, and this is going to be your e power I omega tau, and the integration is with respect to omega. Now, as we said, keep it in mind, depending upon the input, this exponential function will be kept as such, or it will be expanded as cosine sine. When it is going to be constant, this is not going to affect this function in any way. Therefore, what do? We keep it as such. If it is going to be exponential, in exponential also, this can be better combined with an exponential, so we keep it as such. Only in terms of if we have an algebraic expression as input, then we split this exponential as cosine sine. Now since this 1 is going to be a constant, this 1 comes outside, so it becomes 1 divided by 2 pi integral from e power I omega tau d omega. With respect to omega, which is a constant, I and tau are going to be constant and omega is going to be my variable. So e power I theta on integration gives you e power I theta divided by theta. What is going to divided by I? What is going to be the constant part? I will have to integrate divide by. The constant part I will have to divide by will be my I tau. This has to be applied between the limits omega naught and minus omega naught. Moving to the next slide, what we will have is, this is going to be 1 divided by 2 pi e power, this is going to be equal to I omega tau divided by I tau between the limits omega naught and minus omega naught. I tau is a constant, let me pull it outside. 2 pi I tau. Omega is my variable, which takes the upper limit omega naught and takes the lower limit minus omega naught. So you have e power I tau upper limit minus e power I tau lower limit. What is the lower limit? Minus omega naught. So minus sign comes outside. Now you think, consider this is of the form e power I theta minus e power minus I theta. What do we know about e power I theta minus e power minus I theta? If we have divided by 2i, I can replace and write this as sine theta. Now what is in place of theta? Tau omega naught. Okay, so let me bring this 2 and I inside. So I will be left out with pi and tau outside. So you have e power I tau omega naught minus e power minus I tau omega naught divided by 2i. So now I can replace this by sine of, what will be my theta? In place of theta, I have it as tau omega naught. So my sine tau omega naught divided by pi tau is going to be my final answer. Keep it in mind, this is going to be an angle, and what we have written in the denominator is going to be a constant. At no point of time you are supposed to cancel off this tau and this tau, because an angle cannot be cancelled off with a constant. So don't do that mistake. Now the problem is over for us and is as easy as that. Thank you very much.